The Jaws That Jump by Adam Summers. Copyright 2006 by Natural History Magazine, Incorporated. Recently, I was reminded of just how powerful ants can be when inflicting damage on intruders. A team of biomechanists has studied the incredibly speedy bite of a group of Central and South American ants. The team clocked the bite as the fastest on the planet and discovered that it also gives the ants the unique ability to jump with their jaws, adding to an impressive array of already known defenses. Trap-jaw ants nest in leaf litter rather than underground or in mounds. There they often feed on well-armored and elusive prey, including other species of ants. As they stalk their dinner, the trap-jaws hold their mandibles wide apart, often cocked open at 180 degrees or more by a latch mechanism. When minute trigger hairs on the inner edge of the mandible come in contact with something, the jaws snap shut at speeds now known to reach 145 miles per hour. No passerby could outrace that. The astoundingly high speed gives the jaws, despite their light weight, enough force to crack open the armor of most prey and get at the tasty meat inside. The key to the jaws' speed and their even more amazing acceleration is that the release comes from stored energy produced by the strong but slow muscles of the jaw. Think how an archer slowly draws an arrow in a bowstring against the flex of a bow. Nearly all the energy from the archer's muscles pours into the flexing of the bow. When released, the energy stored in the bow wings the arrow toward its target much faster than the archer could by throwing the arrow like a javelin. The biomechanics of energy storage is the domain of Sheila N. Patek and Joseph E. Bio, both biomechanists at the University of California, Berkeley. They teamed up with two ant experts, Brian L. Fisher of the California Academy of Sciences in San Francisco and Andrew V. Suarez of the University of Illinois at Urbana-Champaign, to look at the trap-jaw ant, Odontomachus bari. Fisher, Suarez, and other field biologists had already noted that catching O. bari was like grabbing for popping popcorn, and very hot popcorn at that, because a painful sting goes with an ant's trap-jaw bite. The insects bounced around in a dizzying frenzy and propelled themselves many times their body length when biologists or smaller intruders approached them. Patek and Bio made high-speed video images of their movements and discovered that the secret of their self-propulsion was the well-executed, quote, firing, end quote, of their mandibles. They also observed that mandibles started to decelerate before they meet, possibly to avoid self-inflicted damage. Most important, the ants had two distinct modes of aerial locomotion. In the so-called escape jump, an ant orients its head and jaws perpendicular to the ground, then slams its face straight down. That triggers the cocked mandibles to release with a force 400 times the ant's body weight, launching the insect 10 or more body lengths nearly straight into the air. The ant doesn't seem to go in any particular direction, but the jump is presumably fast and unpredictable enough to help the insect evade, say, the probing tongue of a lizard. Not only can the jumping ant gain height and sow confusion, but it may also get to a new vantage point from which to relaunch an attack. The second kind of jaw-propelled locomotion is even more common than escape jumping. If an intruder enters the ant's nest, one of the ants bangs its jaws against the intruder, which triggers the trap jaw and propels the interloper, if small enough, in one direction out of the nest and the ant in the other. Often the force sends the ant skimming an inch off the ground for nearly a foot. The attack, for obvious reasons, is known as the, quote, bouncer defense, end quote. In the wild, gangs of defending ants team up to attack hostile strangers, sending them head over heels out of the nest. From an evolutionary point of view, the trap jaws are an intriguing story. The ants clearly evolved an entirely new function, propulsion, for a system that was already useful, chewing up prey. Several lineages of trap-jaw ants have independently hit on the tactic of storing energy in their jaws to penetrate well-defended prey. In Odontomachus, the horizontal bouncer defense jump could have arisen out of attempts to bite intruders, but the high escape jump with jaws aimed directly at the ground must have arisen from a different, perhaps accidental kind of behavior. Such a serendipitous event would have been a rare instance in which banging one's head against the ground got good results.